Last time we got the traffic light outputs working. Red, yellow, green, cycling automatically. That's only half the job. There's no input, no interaction. It's not a real automation program yet. So in this video, we're going to fix that. We're adding a pedestrian crossing button, and more importantly, we're going to stop copy-pasting code altogether. Instead, we're going to let the AI write directly to the project file using something called an MCP. Now, this MCP isn't an official CODESYS release. It's open source, and it works by running Python scripts through CODESYS' scripting engine in the background. It gets the job done, but it comes with a couple of important limitations to understand. The first one, CODESYS project files are stored in binary format, which means the AI can't open and read them directly. So instead of reading the file to understand what's already in your project, the AI has to rely on the conversation history. That's why we stay in the same chat session throughout. As long as we don't start over, the AI already knows what code it wrote, what the project structure looks like, and what still needs to change. Start a new session and that context is gone. The second limitation, the AI can only write to the project file when CODESYS is closed. You can't have the file open at the same time. So the workflow becomes close CODESYS, run your prompt, let the AI write and build, then reopen and test. Here's what we want to add. There are pedestrian crossing buttons on the north-south and east-west directions. When a pedestrian pushes a button, the traffic lights should immediately jump to red, giving pedestrians a safe window to cross. After 10 seconds, the lights return to their normal cycle. Simple concept. Let's see how the AI handles it. Let's bring Claude back in the same session. Here's the prompt I wrote. I asked it to add an asynchronous state machine for the pedestrian crossing buttons, one for north-south, one for east-west. When either button is pressed, the corresponding direction goes red for 10 seconds, then returns to the normal state. And then at the bottom, I added this instruction. Please update the code using CODESYS MCP tools, build the new features, and correct any build errors until the project compiles successfully. The project file is located here. That last part is the key. That's what tells the MCP where to find the file. Write the changes and verify it builds, all without me touching anything. Let me run it. Well, Claude is done. Okay, CODESYS is back open. Let's see what it did. Right away, I can see a lot more code than before. It's actually more complex than I expected. More elaborate than necessary, but let's not judge it yet. Let's see if it works. It compiled. Let's download it to the PLC and run it. Done. Let's run it. Before we test the button logic, we need to map the physical inputs. The buttons are wired into inputs 1 and 2 on the hardware. I need to log out, assign those to the pedestrian north-south and east-west variables in the I/O map. Then log back in and download again. The light cycle is running. Let me push the pedestrian button on the north-south side. It goes red. Great. But here's the problem. Both directions go red at the same time. North-south and east-west are both sitting at red for the full 10 seconds. Then east-west goes green, yellow, red, and the cycle resumes. That's not right. When the north-south pedestrians are crossing, east-west traffic should go straight to green, not wait at red. They're not conflicting directions. Only the side where the pedestrian is crossing should be held at red. Let me go back to the AI and explain exactly what needs to change. I described the issue clearly. When the pedestrian button is pushed, both sides go red, but in reality, only the crossing direction should hold red. The other direction should resume green immediately. I asked it to show me how it's going to fix this, and reminded it to close the project first so the MCP can write to the file. Let's wait for it to finish. Okay, it says it's done. Let me open the file back up. Something's off. The program is there, but the decoration, it's all gone. Surprisingly, the code compiled. That must be a bug. This is one of those moments where you really do have to know what you're looking at. If I just trusted that it compiled and called it done, I'd have a mess of a project. Let me exit CODESYS first. Let me go back and tell it exactly what happened. I told it the decoration was missing and it needed to restore it without breaking the logic fix it just applied. It's done. Let's open it in CODESYS. Check the timestamp on the file. Yep, it's brand new. Let's open it. It's back. The declaration looks right. Let me build it again to confirm. Build successful. Download. Run. North-south goes red. East-west jumps straight to green. "10 seconds pass. North-south resumes the normal cycle." That's exactly what we wanted. So what did we actually prove today? First, yes, AI with MCP can write PLC code directly to your project, no copy pasting. It wrote the feature, built it, and iterated on it autonomously. Second, it's not foolproof. It introduced a logic bug on the first try, and it wiped the decoration on the fix. 2 issues in 1 session. And that's the real takeaway. This is an incredibly powerful tool, but you still need to know what you're doing. You have to be able to recognize when something's wrong, describe the problem clearly, and verify the output. The AI doesn't replace the engineer, it just moves a lot of the heavy lifting off your plate. I'll be honest, I'm still pretty new to CODESYS myself. The reason I've gotten this far is because I've been asking the AI to teach me along the way. And that's maybe the best use of all. Not just writing code for you, but helping you actually learn. Next time, we're going to take this a step further and build out a proper AI-assisted PLC workflow, end to end. That means using an agentic coding tool like Claude Code or Codex as the brain, setting up a project directory with a markdown instruction file so the AI always knows the rules of your project, connecting GitHub to track every code change along the way, and using MCP to write and build directly into CODESYS. Just like we did today, but more structured and repeatable. Is it a perfect workflow? Not yet. But it's real, it works, and it might change how you think about writing PLC code. See you in the next one.